So this is what we just traced out along the great circle. Our strike is still at the south here. Our great circle went through, or our drawing along great circle went up and through our dip measurement. And what we can do now is rotate our stereonet back to north, where north lines up with north behind it, and you'll see we now have a line going across our stereonet. Remember, since we're now in 2D, planes are represented as lines. If we were in 3D, this plane would be coming out like this, right? Let's go back again and check our dip measurement. So we had 115, striking 115, strike is down here, 44 degrees to the northeast. The curved line, whichever way it's curving towards, is the way it's dipping. So it's curving out towards this way. Our dip is that way. If straight ahead, if this is north up here, we are dipping towards the northeast, approximately in the middle, right? 44 degrees is half of 90, approximately in the middle. It makes sense. It's always important to go back, especially when you first start doing these stereonets, and to just do a check, do a quick check. You know, whichever way it's curving is the way it's dipping. And you can check real quick if you might have switched the dip. It's very easy to rotate your stereonet wrong, and this is completely flipped to where it's actually like this. And that's what it would look like if our plane wasn't dipping like that, but if it was dipping like that. So that was our plotting a plane on a stereonet. What we're going to do now is, from this plane, we're going to plot our pole. So remember, our pole, if we're dipping like this, our pole goes through our plane at 90 degrees. So if it's dipping like that, our pole should plot somewhere over here. We should have a point. And remember, we do this because if you have a large, large amount of data from a field site, it's a lot easier to quantify that data, analyze that data, if you can actually see it. What I'm working on my thesis right now is I have a whole bunch of planes in one stereonet to where there's almost no white space left, and it's extremely difficult to see anything, and that's why you translate your data to points. You can fit a lot more on a stereonet, and it's easier to see trends. So how do we plot a pole? What we're going to do is, we know it's 90 degrees from our plane. So we are going to rotate our plane back to where our strike hits north-south. Where our strike hits north-south, we know that going in on the horizontal will be exactly perpendicular to our strike. So remember, a pole is 90 degrees to our plane. So if our strike is now perpendicular to our dip, we can count across along this horizontal line 90 degrees to our pole. I'll do it once one way and once the other way to show you that no matter which way you go, your pole will be in the same position. So we're going to count 90 degrees along this horizontal. So it was at 44 degrees. That's one line in, two lines in from this thicker line. So we can go 10, 20, 30, 40, 50, 60, 70, 80, 90, and put a point. So we moved 90 degrees across this line and put a point. Now I'll show you, you can also go to the right and you'll still get to that point. So if we go this way, 10, 20, 30, 40, start over here, 50, 60, 70, 80, 90, we're still at that point. So right now we've plotted a pole 90 degrees from our plane. Now if we rotate our stereonet back to north, we can see that our pole is now plotted over here. Remember when I made our plane with my hand, it's dipping like that. If the plane's dipping like that and I stick a line in 3D space into it, it should hit that pole. Alright guys, I hope this made sense. We'll be going over a little more on Friday, and I'll definitely do another example in class. This is just a pre-lab video to help you understand stereonets and how to plot on them.